Welcome back to the Deep Dive, everyone. Today, we're going really deep on something that I think, you need to know about, but you probably haven't wanted to dig into just because it's so big, so complicated, and, there are all kinds of different opinions about it, but it's something that's increasingly becoming more and more important.
Yeah, I think that's right. We're talking about big data, and our guide in this exploration is the Stanford Encyclopedia of Philosophy entry on big data.
Yeah, and we're not just talking about you know, tech stuff or data science. We're talking about what it means, like
Yeah.
the deep philosophical questions that come up when we try to make sense of this massive amount of information. We're going to kind of be acting as philosophers in this deep dive.
Exactly.
Okay, so before we get too philosophical, let's start with the basics. What is big data anyway? I mean, we hear the term thrown around all the time, but what makes it big?
Well, I mean, yeah, the most obvious thing is the sheer size of the data sets. Like, think about all the data generated by social media or online shopping or, scientific experiments.
Yeah, I mean, I get that it's a lot of data, but is it just about the volume, the sheer number of data points?
No, it's more than that. Like Boyd and Crawford, they wrote about this back in 2012, and they said it's about the ability to search, aggregate, and cross-reference all that data. And O'Malley and Sawyer, they talked about how big data lets us connect all these different types of information, not just numbers, but like text, images, videos, all kinds of stuff.
Oh, okay. So it's not just a mountain of numbers. It's more about the complexity, the different kinds of information that we can bring together.
Right, exactly. And then there are all these other characteristics that we often use these V words to
Like
describe.
V
Yeah,
words.
so like variety, veracity, validity, volatility, and value.
Okay. Unpack that a bit for us.
Sure. So like variety, that just means, all the different forms that the data can take. And then veracity is all about how trustworthy the data is. Like how accurate is it? Where did it come from? Is it biased? That's a huge philosophical question. How can we even know if big data is telling us the truth?
I mean, yeah. If you
Yeah.
have a mountain of bad data, it doesn't really matter how big it is, right?
Exactly. And then you have validity, which is, are we actually using the right kind of data to answer the questions we're asking? Then volatility data doesn't last forever. File formats change, storage systems become obsolete, and things disappear. So how do we make sure that this vast amount of data remains usable over
I
time?
mean, yeah, that's something I hadn't even considered.
And finally, value. Like, what's the point of all this data?
Right.
What are we trying to achieve with it? Is it scientific knowledge, economic gain, social good? I mean, the value we ascribe to big data really shapes how we use it.
Okay, so it's not just about the size, but also the variety, the trustworthiness, the relevance, the longevity, and the purpose of the data. I'm starting to see why this requires some serious philosophical thinking.
It definitely does. And, one of the things that big data is really pushing us to think about is the role of human intelligence. I mean, we hear all this talk about AI and algorithms taking over, but is that really the whole story?
Yeah, that's the data-driven research thing, right? Like some people were saying that we're reaching the end of theory, that we don't need human insights anymore, that the data will just speak for itself.
Right. And there were these, kind of bold claims, like Anderson was saying back in 2008, that with enough data, we wouldn't need models or hypotheses anymore. And Haidt and colleagues, they even talked about a petabyte age where we could just mine data for answers. But in reality, as Simons and Alvarado have pointed out, big data analysis still relies heavily on things like statistics and algorithms, which are designed and interpreted by humans. We can't just let the machines do all the thinking.
So we're not quite ready to hand over the reins to the robots.
Not quite. And there are these, real dangers in just blindly trusting the data. Like Kalud and Longo, they've talked about how big data can lead to spurious correlations where things seem to be connected just because they happen to show up together in the data, but there's no real underlying relationship. So we have to be really careful about how we interpret those patterns, and that takes human judgment.
It's like, just because ice cream sales and crime rates both go up in the summer doesn't mean one causes the other.
Exactly. And then there's this thing called the curse of dimensionality, which means that the more variables you add to your analysis, the harder it gets to find real, meaningful patterns, even with tons of data. So using AI effectively actually requires a lot of human intelligence, to figure out which variables are important, how to structure the analysis, and how to interpret the results.
So the more data we have, the smarter we have to be about how we use it. And what happens when these AI systems get so complex that we can't even understand how they're working anymore? Like when they become a black box.
That's a really interesting question, and it's something that Thomas Nichols has been thinking about. He talks about the possibility of what he calls alien intelligence, these epistemic systems that are so different from how our brains work that we can't even comprehend them.
I mean, that's kind of scary, right?
Yeah.
They're like, what if we create these AI systems that are making decisions that impact our lives, but we have no idea why they're making those decisions?
Yeah, it definitely raises some ethical concerns. And it gets to this idea of epistemic opacity, which Paul Humphreys has written a lot about. He says that some computational processes are just inherently opaque to us, meaning that we can't fully grasp all the steps involved, even if we tried. And that raises some really big questions about what we can know and understand in a world increasingly driven by these complex algorithms.
Okay, so we've talked about what big data is and about the role of human intelligence. But what about the data itself? Like, what does it even mean to say that something is data? Is it just like a bunch of facts about the world?
Well, that's a big philosophical question, and there are actually two main views on this: the representational view and the relational view.
Okay, tell me more.
So the representational view says that data are basically accurate reflections of reality. Like, think about a photograph or a sensor reading. They're kind of capturing something that's already out there in the world. And philosophers like Hacking and Reinberger have argued that data are these objective traces of our interactions with the world.
So data are like little pieces of the world that we can collect and study.
Yeah, kind of. It's like they have this inherent meaning, and we just have to use the right methods to uncover it. And this view often goes hand in hand with the idea that more data is always better because it gives us a more complete picture of reality.
Okay, that makes sense. But you
Yeah.
said there was another view, the relational view.
Right. So the relational view, which folks like Leonelli argue for, says that data aren't just these static representations, but rather they're objects that we treat as evidence for scientific claims. So the meaning of data isn't fixed, but depends on things like where it came from, how it was collected, and how we're using it.
So it's not just about the data itself, but also about the context, the relationships, and the interpretations.
Exactly. And this view is really good at explaining why big data can be used in so many different ways.
Mhm.
The same data set might mean different things to different researchers depending on their questions and methods.
Okay, that's interesting. So in the representational view, evidence is something that we extract from the data, whereas in the relational view, the potential to be evidence is part of what makes something count as data in the first place.
Yeah, that's a great way to put it. And Connelly has written about how, in the relational view, evidence becomes a category for identifying data, not just a way of using it. And Boyd has this idea of the line of evidence and the enriched line of evidence, which includes metadata about where the data came from and how it was processed.
So it's like the data's history and its relationships are part of what make it meaningful.
Exactly. And this relational view is really relevant to big data because, we're often dealing with these huge complex data sets from all sorts of different sources. So understanding the context and the relationships is crucial for making sense of it all.
Okay, so our philosophical understanding of what data is really shapes how we approach big data and
Yeah.
what conclusions we can draw from it. It's not just a technical question, it's a philosophical one.
Exactly. And this brings us to how big data is challenging our traditional ideas about knowledge and scientific inquiry. Like, what does it even mean to know something in the age of big data?
Yeah, the Stanford Encyclopedia entry talks about this theory-centric view of science. What is that, and how is big data shaking things up?
So the theory-centric view, which has been really dominant in philosophy of science, basically says that scientific knowledge is all about having justified true beliefs about the world. Like statements or propositions that we can back up with evidence. And this view sees data and experiments as tools for testing those beliefs. Like, we start with a hypothesis, and then we collect data to see if it supports or refutes the hypothesis.
So it's all about starting with a theory and then using data to prove or disprove it.
Right. But big data kind of throws a wrench into that because it's often about exploring vast amounts of data without a pre-existing theory. It's more about finding patterns and then trying to make sense of them.
So it's kind of like, the data comes first and the theory comes later.
Yeah, in a way. And this is leading some philosophers to revisit the idea of inductivism, which says that we can arrive at general principles by observing lots of specific instances.
Mhm.
Like if we see enough white swans, we might conclude that all swans are white.
Okay, but isn't that kind of risky? Like, what if we just haven't seen a black swan yet?
Right, that's the classic problem with inductivism. But Williamson has argued that big data and automation actually make inductivism more plausible because we can now analyze so much more data than we ever could before. And Peach has this idea of variational induction, which is a way of thinking about how we can draw reliable inferences from big data, even if we don't have a specific theory in mind.
Okay, so big data is giving new life to this old idea of inductivism. But surely there are still some people who think the theories are important.
Oh, definitely. Like, Waters talks about theory-informed inquiry, which means that even if we don't have a specific hypothesis, our existing theoretical frameworks still shape how we approach the data and what we look for. And Elliott and others warn against just blindly fishing for patterns in the data without any theoretical guidance, because that can lead to all sorts of spurious results.
So it's not like theories are completely irrelevant, but maybe their role is changing in the age of big data.
Right. And Leonelli has this idea of classificatory theory, which basically means that the way we classify and organize data is itself a kind of implicit theory. So even if we're not explicitly using a theory to guide our analysis, our choices about how to categorize the data are still shaping how we understand it.
That's fascinating. So big data is making us rethink not just what we know, but also how we know it. And what about the whole issue of causation versus correlation? That seems like another area where big data is changing things.
Yeah, absolutely. Big data is really good at making predictions, like predicting what you're going to buy online or who's going to win an election. And Napolitani, Panza, and Strupa have argued that prediction is often the main goal of big data analysis, even if we don't fully understand the underlying causal mechanisms. They call this agnostic science.
So we can know what's going to happen without knowing why it's happening.
Right. And this is kind of a departure from the traditional scientific focus on understanding causal relationships. But some people, like Dereg, argue that understanding is still important, even if we can make accurate predictions without it. And others, like Ratty and Peach, have explored how big data can actually be used to support causal reasoning.
Okay, so big data is making us rethink the relationship between prediction and causation. But isn't it hard to establish causation from big data? Like with so many variables, how can we be sure what's causing what?
Yeah, that's a major challenge. Canali has written about how the heterogeneity of big data, meaning the fact that it comes from so many different sources, makes it really hard to draw causal conclusions. And there are all sorts of logistical and semantic issues like, do we have all the relevant data? How reliable is the data? How are we categorizing it? And so on. So while big data offers these amazing predictive capabilities, the question of causation is still a really tricky one.
Okay, so we've covered a lot of ground here. We've talked about what big data is, the role of human intelligence, the nature of data, the relationship between data and theory, and the challenges of causation. But there's one more really important issue that we need to touch on, and that's the ethical dimension of big data.
Right, that's a huge one. And the Stanford Encyclopedia entry really emphasizes how values are intertwined with every aspect of big data analysis, from the data we choose to collect to the algorithms we use to analyze it.
So it's not just about the data itself, but also about the choices we make about how to use it.
Exactly. Like, researchers' values can influence which datasets they choose, how they clean and process the data, which variables they focus on, and how they interpret the results. And things like intellectual property rights and access to computational resources can also create biases.
So big data isn't as objective as it might seem.
Right. And Crows has this concept of convenience experimentation, which means that researchers might use certain datasets or methods simply because they're easy to access, even if they're not the most appropriate for the research question. And this can lead to all sorts of unintended consequences.
Like, what if the data we have is biased in ways that we don't even realize?
Exactly. And then there's the digital divide and the data divide, which means that not everyone has equal access to data and technology, which can further reinforce existing inequalities. And philosophers like Douglas and Longino have argued that it's impossible to completely separate facts and values, even in science.
Yeah, so we have to be really critical about how big data is being used and who it's benefiting. And there are some real risks here, right?
Oh, absolutely. Like, what happens when all this data is collected and controlled by a handful of powerful corporations or governments? How do we ensure that it's being used responsibly and ethically?
That's a scary thought.
It is. And the privatization of data can lead to all sorts of problems, like, important data sets being hidden from public view or research being skewed towards commercial interests. And even when data is publicly available, it's often in a format that's hard to access and analyze without specialized tools and expertise.
So it's not just about the quantity of data, but also about who has access to it and how it's being used.
Right. And the complexity of the data landscape itself can be a barrier. Like there are so many different databases and data formats, and it's really hard to keep track of everything. The example from nucleic acids research about the proliferation of biological databases really illustrates this. And then there's the problem of what Leonelli calls rampant conservatism, which is the tendency to rely on old data, even when it might be outdated or inaccurate.
Wow, so there's a lot to think about here. It sounds like navigating the world of big data requires more than just technical skills. It requires us to think critically, to be aware of the ethical implications, and to really engage with these philosophical questions.
I completely agree. We can't just blindly trust the data or the algorithms. We have to be thoughtful about how we use these tools and what impact they're having on our lives and our understanding of the world.
And it's not just up to the experts, right? Everyone needs to be part of this conversation because big data is affecting all of us.
So for our listeners out there, I think the big takeaway here is that big data isn't just a technological phenomenon, it's a philosophical one. It's making us rethink fundamental questions about knowledge, evidence, truth, and ethics. And it's calling on all of us to become more critical thinkers and more responsible citizens in this increasingly data-driven world. So as you go about your day, think about the data that's being collected about you, how it's being used, and what impact it might be having on your life and on society as a whole. Thanks for joining us for this deep dive, and we'll see you next time.